Hello, everyone. It is excellent to have you here today on this Tuesday. It is Tuesday. I know what day it is. So, give me 1 second. Just make sure that I've got everything muted. Okay, I think that you can hear me. I am here. I do know that it's a Tuesday, and that is a good thing, I think. Hopefully you all can hear me too. Just let me know. Welcome. If this is your first time watching the stream, I am Becca. I'm a front-end developer from a small town in Ohio, and I am learning TensorFlow.js, and I am also learning how to stream, so I am doing my best. I also have 4 kids at home, some of whom have COVID, and we are trying to make our way through today. So, second week that we are trying to do this with kids in the background somewhere. Welcome, everyone. Hey, Nick and the Practical Dev. Happy to have you here. Oh, Dominic. So today's stream, I think last week's was about an hour. I think this week's will probably be about an hour too. And just enough to talk through some things and to make sure that my kids do not jump in. All right, thanks for giving me a follow. I am very happy to have you here. And if there's something cool I am supposed to do when people give me a follow, I don't know about it because I am learning how to stream. And I know that people have cool things that they give out on their streams. And I am not that cool yet, but one day I will be cool enough to know how to use sound effects and to give you something cool when you follow me. So if you have tips on that, feel free to give me those tips. Yeah, so this is me learning how to stream, learning how to work with TensorFlow.js. Like I said, I'm a front-end developer, and I am very excited because Gant Laborde has given me this book, which he wrote, Learning TensorFlow.js. And this is what I've been using to help me through this journey. I think I've got a link to Gant stuff here. I did, and then where did it go? Let me grab that link really quickly. Okay, so I will toss Gant's information. Thanks, Dominic. We'll just pretend that I'm doing it all right. There's stuff, info for Gant. That's his Twitter, so definitely give him a follow. If you want to check out more of his stuff, then there's a second link for that. So he's done a course, he has written a book, and I just listened to a podcast. I subscribe to a machine learning podcast, and a new one popped up for me, and it was Gant. I was like, oh, this is awesome. He's really fun to listen to talk about all of this stuff, and he does it so well. So hashtag goals, as the cool kids say. I am going to go ahead and share my screen, but welcome if you're new here. If you want to do an introduction in the chat, feel free to let me know where you're from or what you're interested in, and hopefully we can talk more about that soon. So let's see. Last week we talked about image tensors, and we're going to keep on going with that, and we're going to be using the Inception Model today. So I think we'll do mostly a lot of working with the model rather than talking about other things, just because I am on a time limit until one of my kids has a meltdown. So I am trying to make sure that doesn't happen. So yeah, we're going to be working with a model that works with images today. If you have not caught the stream before, I'm uploading everything to my YouTube channel, which I do not have a link to, but I can get a link out there soon. Yes, starting the meltdown timer. You never know when it is going to happen. I did make them French fries in the air fryer, and it was a very large pile. So hopefully that will be a solid half an hour, unless somebody knocks them on the floor, and then somebody else is certainly going to cry. Because who knows when that floor was mopped last. Oh, okay. So we're talking about types of models, and we have to understand a little bit about what we're doing. And so, again, if you're watching for the first time, I have a jump in and get things working kind of method. So we are talking some of the basics, but we're trying to focus on having fun, being able to use the models, and working backwards a little bit to understanding what each of those pieces is doing. So that's the strategy here, to have fun first and learn along the way. So you are not going to be a TensorFlow.js developer after watching this portion of the stream, but hopefully you'll have some idea of what's going on and be interested in exploring it a little bit more. Okay, so let's see, where do I want to go here? Let me look at where this screen and see if I have the right thing pulled up. I do not. Excellent. Give me 1 second. So here we go. We are going to now go there. I did it. I think this is right. So you should be able to see my face, the chat, and shout out to Nick Taylor again for helping me figure out how to add the chat in here. And here is my screen, which, yes, you can see it in its entirety. So what are we talking about here? Well, there's different types of models, and we're not going to go in depth with it, but it's something that I think for now we're just going to recognize that there are different types and different things to look for. And so the two types that we're really talking about are the layers model and the graph model. So layers models, this is what I have pulled up in the docs here, and I will go ahead and throw that in the chat so you can follow along. That will take you to the layers model, and this is the simplest that we could be using. So you can inspect and modify things and take it apart and do some adjustments. And so this is good if you want to change things up, if you want to retune it a little bit and maybe adjust it later. You'll use this load layers model, which is much more difficult to say out loud than I thought. But now that I'm saying it out loud, it took some effort to make sure that I did not mess that up. And so if we're not talking layers model, then we're talking the graph model. This is the one that's generally more optimized for use, and I think Gantt says it's computationally efficient. But this one can be a little bit more difficult to inspect or modify. And to load this one, it should be here. Let's see. It will be load graph model. Oh, okay. So it's directly above that one. So if you're checking out that link, look at the one above, and this tells you a little bit about what we are talking about. And now I've made my face blurry on the screen. There we go. It came back. It's all good. So these are the different types of models. We'll talk a little bit about the type that we're going to be using with Inception in a little bit. So let's see. There's a couple of different ways to load models as well. Like I said, I'm not going to get in depth into this right now. Definitely the chapter of the book does a really good job of explaining it. And we're on chapter 5. So check out chapter 5. We're talking about loading models, different ways. You can load models via a public URL. You could load them from different locations. What we're going to be doing today is we're going to be looking at the TF Hub model to find Inception. So before we go any further, I just want to give you a little tour of TF Hub. But let's go back to, that's what we are going to get to. Here we go. So we have this this screen here that shows you where different models are housed. These are popular models. This is Google is housing these here, and so the community can use them. And so it takes you to all these different quick links. I think maybe I just can't say anything right today. We've got these quick links to help us figure out, okay, what should we be looking for? And if you're playing around with models and you're trying to figure out what you want to work with, this might not be the place to start unless you're pretty familiar with what you want to do and the things that, how you want to approach the information. TensorFlow does have a repository that has a bunch of demos. Let's see, do I have it up here? I'm trying to remember what it is. TF.js. And then I think there is is it models? We'll see. Yeah, that must be it. Yeah, so if you're playing around, this link will take you, I'm sorry, I always forget to zoom in, to a repository that has different models, it has demos, at least some of them are live, which makes it nice. And you can see, okay, so what model am I looking at? Is the demo live? Where's the source code? It gives you some details and how to run that. So if you're starting out and you just want to see what's going on with these things, that might be a really good place to start. But I think, today, like getting into TensorFlow Hub is going to be, I think, an important step in going forward and learning and progress. And so we know for sure that we want to be working with TF.js because this stream is all about TensorFlow.js. And then once you click there, you can see, okay, this is what's available to me. And some of these will give you more information than others. I have never clicked this, but we know that this is an audio event classification. It gives you a little bit of information about that. And then down here, it will give you more info. So this is actually pretty nice. It gives you the model description, the inputs, and the outputs. But yeah, this is nice too. How you would use the model in TensorFlow too. And so let's see here. So if we click over on TensorFlow.js, then you'll get more of the information. So one of the things that I do want to say about TF Hub, when you come here, if you're using TensorFlow.js, sometimes you can find that these models are used in other forms too. So you always want to make sure that you have selected the right tab. And a lot of times all of the information is not going to be carried over into those other tabs. So I like to use the first one as kind of that first point of education. What am I going to be looking at? What am I going to, what are important things that I need to know for this model before going over to the .js tab? So just something to be aware of, that not all of that information is transferred over, and that you can check out the other tabs for more info. So this is not where we want to be. We do not want to be on Imagenet. Let's see what we can find here. Okay, so we are going to go to Imagenet Inception v3 classification. And so like I said, this is, there's two versions. Today we're going to be working with version 3. And we'll check out this first tab. Actually, version 1, wait, oh, there was a warning. I thought there was a warning with this one. I saw a warning at some point. Oh, it's going away. Maybe because I already clicked away. Anyway, there's a warning that's saying that there's a more updated version of this. So here we go. We have this overview of what we're going to be looking at. It gives us a URL that we can copy, but it gives us some important information. So information that we need to look for is, we need to know the size. So the input image is 299 by 299 pixels. Now last week when we were talking about images, I mentioned that some of the models have specific sizes. So if you give it the wrong size, it's not going to work. So we're going to have to figure out how to make sure that the images that we're using are in the right size. So let's see here. We're going to go ahead and just check out. Whoops, accidentally clicking things I don't want to click. Sorry, I'm moving things around so I can see the full screen here. Whoa, that's weird. Okay, so I already have this code sandbox, which has been a really good way for me to show this information and to pass it along. So if you want to follow along, once we're done, we'll have all of the information here. I have not posted a blog about this week, but I'm also going to post a blog where I'll have the code sandbox in there as well. And I forgot to mention too, we've been doing a TensorFlow.js study group on Fridays. So if you're interested in that, hit me up on Twitter. You can find me everywhere at BeccaHW. We're doing that at 1 p.m. Eastern. I'm pretty sure that's the time. 1 p.m. to 2:10-ish. So trying to keep it about an hour. So if you're interested, let me know. We're just kind of exploring things together so we can talk things through and understand these things. Okay, so I've got this code sandbox going. I wrote some strange thing that I did not mean to write. I will make this bigger in a second. Let's see here. Okay. Now it is totally cut off, so we don't want that. Maybe it's not totally cut off. I think that's good. If it's not good, let me know. I am going to take a sip of water. I'm glad that I announced that since nobody knew that's what I was doing. Okay, so what do we have going on here? Well, we're going to be talking about Inception. So this would be the perfect opportunity for me to use some soundbite from the movie Inception. Except, again, I am not cool enough to have sound effects. But if you have seen Inception and you have a favorite part of the movie, let me know in the chat. Nick is providing the soundtracks and the sound effects in the chat. It is officially beep, beep, boop. And yes, that was directly from Inception. So if you have seen the movie Inception, it is really fun. And this is not like the movie Inception, even though I tried to sell that in my tweet. So I'm sorry if I disappointed you, and I would understand if you all leave. Okay, so we are going to talk about Inception, the model, not the movie, but we can also talk about the movie. So feel free to totally distract me in the chat if there are things that you would like to distract me with that have to do with the movie Inception. Now, see, I think I just made it too big and it can't handle that. All right, there we go. We've got this going now. This is a little bit better. I can close this to Command B. Ha, I know the trick now. Command B closes that panel. All right, so what do we have? Let's see those tensors. We're going to get there. So what do we need? First of all, with this model, what we're doing is we're trying to identify it using the model. So we're going to give it an image, and it's going to tell us what it thinks that image is. And so I have an image here with the ID of mystery, so we can grab that. And then we're grabbing an image from Unsplash. If there is a different image you would like to see us try, let me know. I do have the list, so remember that this isn't trained to recognize every image in the world. This, I think, recognizes 1,001 different things. I could be wrong about that. I know that this list is small. It's not letting me make it any bigger. I'll go ahead and drop this in the chat. But these are the labels that we can look for. So this is how it's going to categorize it. So if you want to look at one of these things, let me know. We can try and find a picture of it. I really wanted to do an axolotl because I was super psyched that there was an axolotl in here. Oh, let me see. AX. Okay, so if you don't know what an axolotl is, I will take myself on a tangent and we will look at what an axolotl looks like because they are super cute and I want to get my kids one for Christmas and I don't know if it's possible. So the reason I know about axolotls is because my kids play Minecraft, but I mean, like, look how cute this little thing is. It's adorable. So it can identify an axolotl, and obviously somebody, Nick, now you know. You are welcome. You now know what an axolotl is. Super cute. Salamanders with spiked hair. There was a description of axolotls, and it was like the new cooler salamander. So I guess that's true. I also saw a very cute video of an axolotl yawning. I apologize. I do not have that video for you, but you can maybe Google axolotls yawning. Look how cute. Oh my gosh, look at this blue axolotl. I'm sorry. I will be done distracting myself. But see there, you can see it's on Minecraft, but also so cute. This stream is not sponsored by axolotls. But I like them and I think they're cool. And there are other things that we can look for, but I chose lobster. I'm not really sure why I chose lobster. Where is our resident lobster man, Todd Libby, when you need him? Maybe that is why. So Todd, for those of you who don't know, has a lot of really, really great information on accessibility. And in our virtual coffee Slack, he is known for giving the lobster emoji to any thread that he responds to with an emoji. So he's just kind of made that his official logo. Our stream is still not sponsored by Pepperidge Farms, but one of these days we are gonna get it sponsored by Pepperidge Farms because wouldn't that be something? Well, let's see. We can definitely check that out, Dominic. I think that would be really cool to check out something that we don't see on the list. I'm trying to click this image and it's not letting me. Here we go. Oh, okay. Whew, that's cool. And it matches with my color theme. So perfect. When we get there, we're going to go ahead and run this and see what happens. So maybe I should stop talking about axolotls and get coding. Okay, so we have this image. Let's test our lobster first, and then we'll go ahead and check Dominic's background and see what happens there. That'll be really interesting. Okay, so we don't really need to know anything else about this index.html except we've got this ID of mystery, and now we need to figure this out here. So what do we need to know for the Inception model? We need to know the size, and we know that the pixels are 299 by 299 because we saw that in the TF hub information here. Yes, right here. So it gives you that info. So we know that we need that. And we also know that when we load from the graph model, we're going to be loading from the graph model. Let's see. What do we need to know here? So if you're loading from a TF hub URL, it assumes that this is false, so you need to set it to true. So we're going to go ahead and start there. And I'm just going to, let's see. Okay. Oh, that's the two separate links, just so we know. We've got TF dot load graph model. And then we're going to give it that. Let's see. Let's go back here. And make sure we're doing the right thing. Oh, we should probably, yep, we could just copy this. Okay, here we go. TF graph.load model. That is good. And we are going to, what do we need to do from there? Let's go ahead and we need to look at these individually. So then we're going to we're going to look at just one thing at a time. Oops. Okay, so the first thing, okay, so here we go. We've got this set up, so it is in a usable form. Now we need to grab the actual image. So let's see. I guess this would be step 2. To get the image. And we can do this by, let's see, what do we want to call this? Const image. We'll just call it image for right now because that's as much as I can do. Document dot get element by ID. And we said that that ID was mystery, although it's not a mystery. Mystery. All right, so we have the image and we have loaded the model. And the next thing that we need to do is we need to give it the image in a usable form. Okay, so step 3. Give model image in usable form. So what does that mean? Well, that means that first of all, last week we know that it can't take that just as an image. Because images are created from pixels and we need to convert that to tensors. And so the first step in this would be to convert it from into tensors. And I think we learned this, or we talked about this last week, but from pixels is what we are going to use here because we want to take the image and translate it from pixels into tensors so our model is able to use it. So we are going to do tf.from pixels, and then we're going to, oh wait, no, that's wrong. It's tf.browser from pixels. So let's not forget that. And actually, I think I called it an image, so I can copy that entire thing and make it easier on myself. Yes. Did I delete something I shouldn't have, though? I think I did. So let's make this a little bit bigger. All right, so we've got this. We should save this into a variable. Let's see. Tensor, we'll call it tensor image with an img instead just because it's quicker. And so there's still more that we need to do here to make this usable. So this was step 1, but we need to resize this as well. And we're going to use this method called resize by linear. So you can see it here. Maybe. Okay. So this is where, let's see, bilinear resize a single 3D image to a new shape. So who remembers what shape we need for this? What pixels do we need? We need 299 by 299. We need to change that size. So let's see here. We need to do, let's save this again. So const resized image. This is getting confusing. I'm sorry. Not doing great with my variable names today. We are going to but say this is my best at this point. Okay, so we want to resize this image, and so we have to take tf.image.resize by linear. That's what we want here. and then we want to pass it the tensor image. And then from there, we need to give it the correct size, 299 by 299. And let's see. Okay, I know we need to pass it true as well. So images and size, we're going to go ahead and pass it true. I am going to be honest here. I'm not sure what we're saying true to, but because I know that it needs to happen and I know that I want to get this done before the meltdown happens. Call most functions do it. That seems like the right way to go, Nick. Mine is very excellent with show image. I've done this great naming there as well. So, all right, we have this resized image. We have to do a little bit more work here. And I know, again, let's see, .div. We're going to be using this operation here. We're going to be doing two more things that we need to get this ready. So we need to do .div, and then we need to do a final reshape, I believe. Reshape. I don't think it's layers.reshape. I think it's just .reshape. So let's go up. Yep, tf.reshape. This is what we need. So these are the two things that we do need to get it into the working condition that we want it to be in. Again, Gantt covers this really well in the book, and I'm just trying to make sure that you know what we're looking at and that I explain as much as I can. I will, like I said, have a blog post out about this. And let's see how we need. So then we need a .div. And we are, let's see. Okay, so this is converting it again. We're normalizing the data here with this. And then finally, we are going to reshape. And what do we need to reshape? We need to convert this. It's a 3D tensor. Okay, but the model expects a 4D tensor. So we have to make sure that this happens. So this is where we're getting the reshape from. And I'm sure that back here on the TF hub, again, why does it look so small on the screen? It should give us that information as well. So let's see here. Okay, the number of classes, 1,001 classes. That's where that number did come from. I did not just make it up. The images are expected to have color values between the range of 0 and 1. Oh, that was interesting. Expected size of input is 299. Okay. All right. So we've got a lot of information there. Again, something to go back to. I did throw that link into the chat. Let's see. Okay, because I reshaped it, but I didn't give it any of the information that we need in here. So that is useful. What does it take? It reshapes to a given shape, given an input tensor, returns a new tensor with the same values as the input tensor with shape. Okay, so what we're going to do here is, let's go back here. We are going to give it, I think we need to give it 299 again. 299, 299, and we want it to know that, let's see, we're going to pass it a 3, I believe. Let's see here. Okay. Oh, wait. 299, 29. Let's go back here and see what we've got. reshape 2 by 2. If the shape is 1D or higher, then the operation returns a tensor with a shape filled with the values of the tensor. In this case, the number of elements implied by the shape must be the same number as the elements in the tensor. Okay, that we know because we talked about that. An array of integers defining the output of the tensor shape. So let's see here. Well, I think we need that 3, but I'm going to get rid of it for a second, and then let's see if we can. Nope, it does not like that. It says absolutely not. Size, match the product of the shape 299. Okay, wait a minute. Do I need brackets? I think I need brackets. We need brackets. So maybe, let's see. Give it a 3. Oh, it does need that 3. So there we go. Definitely need that 3. Let's go ahead and see what happens. Let's console log this resized image just to see what this looks like. Where did that go? Nope. Okay, let's see what happens here. I am a huge fan of console logs just to help me see, like, okay, what am I looking at here? Looks like we've got some problems. We'll see what's going on there in a second. Okay, so here we go. I feel like this is good news. We've got a tensor. I always have such a hard time figuring out this console. All right, so we do have a tensor. Hooray! That's what we want. And I don't know, do you see this? No. Okay, so it looks different on your screen. Right now I can't see anything in the console. Now it finally came. I was doing some very weird mouse over thing that looked magical, but you did not get to see that, so I am sorry. Okay, so we have a tensor. These are some things that we talked about that are important to look at when you're looking at this information. So what type is it? It's a float 32. We see that the shape is an array, so 299 by 299. And let's see, what else do we normally look at? Rank type is a 3. So those are all good things, I believe. Well, it looks good because we have a tensor. Let's see what this problem is. It's not loading. It's doing the weird mousy thing again. Here we go. Inception classes is defined but never used. Oh, we're getting there. We're getting there. It's not a problem. Don't worry about it. Okay, now let me try and close the console. Since I am not good at that. Okay, so we do have a tensor. That is good news. This is what we want. Now we should probably predict what's going on there. So let's see. Model. Let's see. Console. No. Do we need? Let's give it a variable. Just giving everything variables today. Results equals model.predict. So it knows this is what we're doing, and then we're going to call this resized image img. Is that what we did? Img. Yep. Nope. Yes. Model.predict. Okay, so that's not working. Let's figure out, oh, maybe this needs to be, no, we have this, so we should, okay, oh, okay, here we go. This is good. Nice, good job hovering over the error and reading it. Okay, so the shape of images provided in model.execute must be -1, -1, -1, 3, but was 299, 299, 3. So we're definitely missing a number in that array. We're going to go ahead and give that a 1. and see what happens there. It likes that. We've got 4 things happening now. All right, so we've got these 4 things and we have the results maybe, but let's see here. Results dot print. Okay, so this gives us a bunch of numbers. And so you might think like, okay, how is that helpful in any way, shape, or form? Well, if we remember, each of these numbers is giving us some indication of how closely related to the label it is. Okay, so this is giving us like the percentage, I believe. Let's figure out what we need to do to make this usable. That's going to be our next step. So where are we at? Step 3. I guess maybe this is like step 4. Let's get usable results. How about that? Step 4. Get usable results. And I just realized that I put a question mark here and I don't need one. So we're going to get some usable results. That's the next thing that we need to do. So let's figure this out. So one of the ways to do this, there's a method called TOPK. And one of the things that I recommend if you are learning TensorFlow.js now, and I'm talking about like, let's use this method or that method or operation, then you might be like, okay, how would I have ever known that? I know it because I read through the book, and so I'm familiar with these things. And this is why I think like having something to follow along with has been super important to me. Or looking at existing models and demos and seeing what they're doing with things helps you to get familiar with like, okay, what is available to me that I can work with in this scenario? And going from there, I think, is one of the ways to start to remember these things, because if you've been a developer for any amount of time, you recognize that like, okay, there are things that you know now that you certainly didn't have access to in your toolbox of coding things until you started to understand a little bit more and learn about those things. So I'm going to take a sip of tea. I got this. We are not sponsored by Ember Mug either, but I have an Ember Mug. Shout out to Kayla Sween, who organized Magnolia JS online last year. I was a speaker, and Virtual Coffee helped out with the lunchrooms, and so this was part of the speaker gifts that she sent, and it has been awesome now that it's like 30 degrees outside. So I've got some elderberry lemon balm tea. We're also not sponsored by them. Okay, so we're done with our not sponsorship breaks, and we are going to get this information in a much more usable form. Okay, so I was talking about top K. Here we go. So it finds the values and indices of the K largest entries along the last dimension. And so there's a lot of information here, but what we want to know is we're going to go for our top 3 here. We want the top 3 answers. So now what do we need to do in order to get those top 3 answers? Well, let's go with, we're going to go exactly with what they have here, except we're going to we don't want A because that's not a thing here. We want the results. And then it does not like that. Great. Excellent. What? It just needed a minute. I was having a little a little bit of a hard time adjusting to that. So here we go. Let's do indices dot print, see what that looks like. We'll just take a look at both of these things. Go away. All right, so here we go. We see that has narrowed it down. We don't have an infinite number of numbers, and we'll go to values.print. What do we got here? Something that's a little bit different. Okay, so it looks like we definitely have fewer things here, which is good. This is what we want. But we are not done yet. We're going to look into what is data sync? Okay, this downloads the values from the tensor. Okay, so we're going to need that. It blocks the UI thread until the values are ready, which can cause performance issues. Well, I'm not sure that we really need that right now. We're just going to be safe here, and we're going to use this. So we're going to say, well, in the book, Gantt calls it winners, so we're just going to go ahead and call it winners too. Winner, winner, chicken dinner. Equals indices dot data sync. Go ahead and call that here. And then we are going to, okay, so we have, what is going on? You're too big, go away. New, get smaller. Here we go. We have the labels. Let's see, Command B, bring it back. We have our labels here, and these are being exported as Inception classes. So this is where we're going to bring this in. Now we need this information so we can figure out what it thinks this image is. All right, so get rid of that, and we'll go back here. We've got these. Okay. All right, I deleted some of my code from my previous sandboxes that gave it to us in a pretty little list. And I don't really want to take the time to figure that out right now since we're coming to about the last 10 minutes. And I want to get to Dominic's question. So we'll just console log these. See, console.log. And then we're going to figure out, okay, so we'll do first place, and then comma, we're going to take Inception classes, and then from there, we're going to figure out winners, winners. And then the first winner is going to be at that 0 index. Ooh, it thinks it's a crayfish. It's close. Does it have lobster in here? Or yeah, I'm pretty sure it does have lobster. Lobster, American lobster, and spiny lobster. It doesn't think it's either of those things. It thinks it's a crayfish. Let's see. Let's do a couple more places just to see. I just think it's interesting. It definitely could look like a crayfish, and I wonder what the difference between a crayfish and a lobster is. Second place. We'll do a third place too. Whoops, third place, comma, and this will be. Whoops, this is going to be 1. I think I got that right. Second place. Yep. All right. Oh, undefined. Why is it undefined? I did something wrong somewhere. Well, that's no good. Winners. I guess we should console.log winners. Oh, Crawfish are just a bit tinier. Yeah, so I wonder how they were trying to train that how that works with the difference between a crayfish and a lobster, because they definitely look alike. What? They're not winders. Okay, so there's just one here. I did something wrong somewhere along the way, and I am not sure what the answer is. We resized. We don't need to even hit run because I don't have it showing anything. But ideally, what it would have done, and what I'll go back and fix after we're done with the stream sometime, is it will print out those answers here. So we only have one winner. Indices. And I guess when I console log these things, we did see that because it was only showing one thing. Can the tensor judge size too? Yeah, I mean, I would think so, but if you're looking at the image size, it would really kind of depend on the perspective of how that image is captured, right? Like, I don't know enough about images and photography to know how you can tell the difference between those things. But yeah, that's a good guess. I wonder, let's just do a real quick Google search. Crayfish. And I mean, that looks like a lobster, right? I don't think I would know the difference between that and a lobster, although maybe its claws are fatter. I mean, in real life, I would know the difference, right? Because the size matters. But here, from this perspective, it's hard to tell. So anyway, that's interesting. And also they have a couple of different things here. So Dominic gave us this image from his background. And we're going to go ahead and see what it does when we give it this, which looks like, nothing on the labels, I think, that we can see here. I don't know. It would be interesting if you can go ahead and look through those labels and let's give it a guess. What do we think is going to come out of, oh my goodness, Dominic's background, which looks like this? Some of the things, I'm going to guess, is there a worm? I would guess a worm. DNA strand. Oh, is DNA strand on there? That's a good one. No, I don't think DNA strand is on there. But whatever that is, I think it's all, we're looking at all animals here. A lot of dogs. There are some things that I don't know what they are. I do not think that it will be a dingo. And what is a D-hole? Hey, Ray Deck is here. The purple people eater. I think that you are exactly right. It will be the purple people eater. So I'm going to stop staring at this list. And let's go and add Dominic's to our image, which is in image.html. Come back. Where are you, panel? My shortcut's not working. There we go. Okay. So here we go. We're taking these from Unsplash. We'll go ahead and save that. And what do we get? Oh, let me reload this just so. Results. Oh, wait, here we go. We need to do it like this, though. It's number 108. There is a winner. A jellyfish. There you go. I think that's not a bad guess. So that is jellyfish-like, right? What do we have here? What do we know about this? Okay, interesting. So this is a rank type 4. Where are we console logging this? Go away. I'm trying to make it go away. It does not want to. It is not listening right now. So where else are we console? Okay, so we're printing the results. Oh, I wish that we could see that better. And the winners. So, all right, there you have it. That is a jellyfish. A jellyfish that was steamrolled. Exactly. There we go. We can look at something else. I would like to maybe figure out why we're only getting the top results here. So maybe take a little bit time to walk back through this code and figure out where I missed something that I needed to have. Okay, so we loaded the model and then we got the image. That's what we needed. Now this is where we give it a usable form. Okay, so this I think all should be good. We're giving it one image, right? That's what we want. But we want, when we're looking at the winners, we want to see the top 3 predictions for that image. So we're not, although we're giving it one image, we should be seeing the different winners or whatever is most likely to be that image, most likely to be labeled. Okay, so then we, all right, resize the image from pixels. I think that's pretty straightforward. And then we're going to take that image and do this resizing. Tensor 299, that's the size we needed. We're going to convert it here and then reshape it here. And then we are, oh, thanks Dominic, thanks for being here and letting us check out your background and finding out that it was a jellyfish. I'm very happy that we figured that out before you left. Predict results, model.predict, resized image. Again, this seems like where we want to be. And then values and indices. Okay, do we need these to use values? Oh, here it is. This is silly. I forgot to write 3. I think I said it. Here we go. We want the top 3. So now, actually, let's just cut this out and we should be able to see what our top 3 are. There we go. It thinks it's a jellyfish, a digital clock, or a nematode. I'm not sure what a nematode is, and I feel uncomfortable looking that up live because I have no idea what that is or what is going to come up on my image search. So I will not look at that. Feel free to look at that yourselves and let me know what a nematode is. But those are our top 3. Thanks. Raydex says it is a worm. I am still not going to Google that live because you just never know what you're going to get when you put some things into Google. But I do want to go back, and we had our lobster. I would be interested in seeing where our top 3. Oh, there's an axolotl. I actually think like this is a little bit of a harder one. Let's try this axolotl and see what happens, because there's a lot of background and this blends in a lot to the background. So I wonder if it will be able to get it, or if that camouflage makes it a little bit harder. That looks like not the right link, but oh, it does. It's there. Hello, little axolotl. It thinks it's a weevil, a quail, or a terrapin. So yeah, again, I think that the background really makes it hard for it to guess what this is. Could have been a tiny velociraptor. I don't think that was one of the labels, but we certainly could do some transfer learning and try and teach it these other things. Oh man, it's broken. I just wanted to find a lobster. Oh, the back end is unhealthy. This is all getting so bad. What's going on, Unsplash? We broke Unsplash. Well, I think maybe this is the point where we end this stream, because we have successfully broken Unsplash. Wow. Well, looking at the Inception, I think that's all part of it, right? Like, was that part of the Inception? I'm not really sure. But I want to say thank you everyone for being here and for sticking with this. We did not have a meltdown from my kids at any point, so I'm going to consider this a success. And normally I would say, let's keep going because we don't have a meltdown. But this is probably when I should stop so we don't get that meltdown. So thanks for being here. I will be back again next week at the same time, 1 o'clock on Tuesdays. And we have a study group on Friday at 1 p.m. Eastern. So if you are interested in coming to that, hit me up on Twitter, and I will see you all later. Thanks.